All right, everyone. I don't know what today is. I've really forgotten what day it is. But at any rate, whatever day you're doing this, it is section 8.3, adding and subtracting rational expressions. I'll do this as quickly as I can. Our learning target today is to be able to add and subtract rational expressions. So up to this point, we have graphed them and we have simplified them and we have multiplied and divided rational expressions. So that means something that has a fraction and a variable in that fraction. So when you're adding or subtracting rational expressions, it's like adding or subtracting numerical fractions. So when you do that, you must have a common denominator. For example, if I wanted to add 1/5 plus 2/5, if I didn't have the common denominator, I would have to create one. But since I do, I just bring over the common denominator and then I do what it says at the top. So 1 plus 2 is 3. So 1/5 plus 2/5 is 3/5. Number 2, I don't have a common denominator. So when I don't have a common denominator, I actually have to make one before I can add them. So 6 would be common to both of those. So what I'm going to do is change both of these to denominators of 6. And in order to do that, I'm going to have to multiply the top and the bottom of this fraction. 2 times 3 is 6, and 2 times 1 is 2. Plus, this 6 is already there. So technically what happened, I just multiplied the top and bottom by 1. So I brought that over. And therefore, I don't add the denominators. I just bring the denominator over. That's the common part. And then I'll add 2 plus 1, and 2 plus 1 is 3. And you can reduce 3 over 6. 3 goes into 3, 1, and 3 goes into 6, 2. So 3 over 6 reduces to 1/2. So the same concept is true when I get ready to add or subtract rationals as well. In order for me to add them, I must have a common denominator. So when I look at these two fractions, 7 over 4x plus 3 over 4x, I see they already have common denominators. Now, by common denominators, that means exactly the same. So since they're already common, I'm going to bring over the 4 and the x, and then I'm going to do what it says at the top, 7 plus 3. And 7 plus 3 is 10. Now, I do have something I can reduce because a 10 and a 4, I don't have any variables at the top, but I do have something that I can simplify here. 2 will go into 10 5 times, and 2 will go into 4 2 times. And so this will reduce to a 5 over a 2x. And that's the simplification of adding and subtracting rationals. The next one, same thing. I look to see, I have a 6x and an 8x. Well, they're not exactly the same. So what I'm going to do is have to make or create common denominators. So the first thing I'm going to do is look at the 6 and the 8, and I need the smallest factor that both of these will go into. It's called the least common multiple. So a 6 and an 8, the smallest thing that I can think of that they will both go into would be a 24. Now, if you don't get this right, let's say you get a number too big, it's okay. You'll just have to reduce it at the end. But I am going to have both of those variables too. So I need an x at the denominator of both of those. So here's how I change the numerator. So 6 times what is 24? That's a 4. So what I had to do is multiply the top and bottom by 4. So 7 times 4 is 28. And 4 times what is 24? So it's a 3. And I already have the variable, so I don't have to change it by multiplying by another variable. So 8 times 3 is 24, and 5 times 3 is 15. Okay, bring over your common denominator, which is 24x. And then I need to add 28 plus 15. And if you have any doubt about how to do that, please use your calculator. So I've got a 43. And so this simplifies to a 43 over 24x. Now those two are when I have monomials or just one term at the bottom. So what's going to happen when I get to the next two? I have actually a family. So this one has a binomial and a binomial. And the first thing I do is group the binomials together so that I know I have to have exactly the same kind of denominator before I can add or subtract these. Well, I just so happen to have the same denominator here. So what I'm going to do is take the x plus the 9x. That's going to make a 10x. And then my common denominator is x minus 5. Now, I do keep them grouped together because I have students now who will want to simplify or cross out the x and the 5 and the 10. You can only cross out another family, x minus 5, if you find another one, which we don't have. So therefore, this is the solution of the addition x over x minus 5 plus 9x over x minus 5. Letter D. First thing I'm going to do is group those bottom denominators or anything that is a polynomial together as a family. If I can factor it, I will, but I don't have any factors here. And in fact, my denominator is already the same, x plus 3 and x plus 3. So my common denominator is x plus 3. I don't have to change anything. And I'm just going to add up a 4x plus a 12. So in the numerator, I have a 4x plus a 12, and then I'm going to group that together. Well, the numerator and the denominator are not the same thing. However, upon looking at this a little more closely, I realized that I can factor this numerator. So if I factor that, I would take out, there's a 4 that's common to both. So if I take out a 4, it'll leave me an x plus 3 in the numerator. And then look at that, I already had an x plus 3 in the denominator. Now, I've done everything perfectly legally by factoring, and those two are exactly the same factors now. So my solution is the only thing that's left over, which is a 4. Now, you can't just start marking things out. Like I can't mark out the x, and I can't mark out the 3 and the 12 and make it a 4. I have to do it by factoring out common factors first. Okay, on to the next page. So the next page, we're going to have our first encounter of what if our denominators are not the same and they are not just numerical. First thing I'm going to do is put parentheses around an x minus 3 and parentheses around the x plus 3. They are not the same thing. So what I have to do is create two brand new fractions, and they both have to have the common denominator. I'll have to have an x minus 3 and an x plus 3. I'll have to have one of each. This one, the new fraction, will have x minus 3 and an x plus 3. They both have to have each one of those. So when I go back to look at putting these now my new numerators, I already have the x minus 3, so the one I'm missing is this one. So I'm missing x plus 3 over x plus 3. That's how I made this one become x minus 3, x plus 3. So in the numerator, I'm going to go ahead and distribute this together. 5 times x is 5x, and 5 times 3 is positive 15. Then there'll be the plus sign in between, and then I see that I already have the x plus 3, and the one I'm missing is x minus 3. So I'm going to multiply by x minus 3 over x minus 3. Now, I've checked to make sure this is a plus, because if it's not, I'm going to have to do one more step. So distribute this, so it's plus 6 times x is 6x, and 6 times negative 3 is negative 18. Perfect. Now, I have common denominators, so I'm going to draw one big fraction. I'm going to put the x minus 3 and the x plus 3 together, and then I'm going to do exactly what it says at the top. So I'm going to say 5x plus 6x is 11x, and I'm going to mark those two out. I've added them together. And then 15 plus negative 18 is a negative 3, and I'm going to close them up as a group. Now, before I say I'm finished, I need to make sure that there's nothing that'll factor out of the numerator. I could find that I have a common factor, and then I could cancel something out, but I don't. 11 and 3 have nothing in common, so therefore, the addition of those two fractions, rational fractions, are 11x minus 3 over x plus 3 times x plus 3. Now, you don't have to multiply the denominators out. I'm perfectly fine if you leave them just like it is. However, if you look on your SAT, it may give you the solution like this, x squared minus 9. Because if you FOIL those two, your middle terms cancel out. So these two are exactly the same thing. Okay, one more example. So my final example letter F, I'm going to put the parentheses around the two denominators because they are absolutely both different. So before I can subtract these, I have to make two brand new fractions. And the first thing that I'm going to do when I notice there's a subtraction here is I'm going to change it to plus a negative. And if you'll do that, it's going to make your life a whole lot easier. Okay, so I have an x plus 5 and an x plus 1, and I need both of those. So I need an x plus 5 and an x plus 1 as my new denominator. This is what makes them both common. So an x plus 1. The one that I'm missing from my first one, I have the x plus 5. So what I need is the x plus 1. So what I'm going to multiply through by is x plus 1 over an x plus 1. That's how I get the denominator to become x plus 5, x plus 1. And in the numerator, I'm going to distribute that. So 3 times x is 3x, and 3 times 1 is a positive 3. And then I'll move over to the next fraction. I have the x plus 1, but I need the x plus 5. So what I multiplied by was x plus 5 over x plus 5. Now remember that this was subtraction, so I changed it to plus a negative. And now I'm going to distribute the negative 4 to both terms. And that's going to keep me from making a simple mistake. So negative 4 times x is negative 4x, and negative 4 times positive 5 is a negative 20. Perfect. Now, I have my common denominator, so I'm going to draw one fraction and put both denominators together. X plus 5, x plus 1, and then I'm going to do what it says at the top. Now, I've already distributed the negative, so I don't have to worry about subtracting. All I have to do is add the opposites that I have. So a 3x and a negative 4x gives me a negative x, and a positive 3 and a negative 20 gives me a negative 17. Now, I could factor out a negative, but it's not going to match up with any of these factors that I have at the bottom. So I am going to say I am finished. Okay, so what you have seen is a demonstration of how to add and subtract your rational equations. This is one of the harder things that we'll do, so if you want to get a little extra help with this, let me know. We don't want you to share those things, not sure where they're coming from. Let me know. I know that we only have a couple classes left, but in order for you to be successful next year in your trig stat class, you're going to need to know how to do this. If you're planning on taking your SAT, let me know as well, and I'll be happy to give you a further explanation and more help with this as well. Okay? Have a great day, everyone. I'll be back with one more lesson tomorrow.